Okay, hello class. So I'm Dr. Fanman here. We're going to come back to the last segment of this topic about CFCs. So in this last juncture, we're going to talk about the replacement of CFC. As we have known that the chlorofluorocarbons are very harmful to the atmosphere because it depletes the ozone layer. So what can we do about it? We find substitutes that's less harmful but can work in the same effectiveness and efficacy. So for instance, we know that the CFCs are highly used pervasively in such applications like the refrigerations as a coolant, right, because they have a high specific capacity, and air conditioning, they most likely exist as a liquid here. So if we replace CFCs, what can we use as substitutes here? So there are other substances, right, that has more fluorine. Remember, fluorine doesn't form radicals because it's the most electronegative element. Unlike chlorine or bromine, they form very stable radicals, and that will deplete ozone. So you can replace these substances of chlorine with fluorine, but at the same time you can increase more carbon. And that's because here, if you just replace with fluorine, what happens is the boiling point becomes low and it vaporizes easily, and this might not be good for the human body. In the other applications, such as the propellants and medicine aerosol here, like I showed you last time, we have this spray here, right? Remember? Oh, this spray. We have other HFCs here, the halofluorocarbons, the hydrogen fluorocarbons, right? Hope you still recall how to translate these numbers, the letters in the formulas here. And lastly, for blowing agents for foams here, there was a foam just by the side here, those foams, right, that has air there. We might not need to use CFC at all here because what you want is just the air here to expand here, right? You notice that as a replacement, right, here we have got 3 carbons compared to a single carbon here. That's because you see that CFC11 here with C triple chlorine fluor, right? That has a very high MR, so we know that the London dispersion forces cause it to have a stronger van der Waals forces. That's why it has high interactions with high boiling point. So in order to have a similar substitute here, the physical property can't differ so large, and therefore we could only replace it with more carbons, at the same time more hydrogen and fluorine. If we just replace it with CF4, it might not work. So in the same strand here, you look at this replacement, HFC 365, doesn't mean the whole year, okay, not the number of days, but HFC 365 MFC, we have got how many fluorines here? 5 atoms of fluorine here, hovering around 4 carbon atoms, okay, as a replacement for this 2 carbon chlorofluorocarbon. So in summary, we use hydrofluorocarbons as a replacement for CFCs, okay. Now for the last slide here, our second last slide. So you see that, right, since we have done the substitutions using the hydrogen fluorocarbons for the chlorofluorocarbons here, you notice how the ozone depletions has decimated. At the same time, you also know that a lot of these CFCs are greenhouse gases. And why are these greenhouse gases? Because when you have a CCl bond here, CBr bond here, they have a potential to stretch like a spring, right? That means they absorb heat, and when they absorb heat, they can release heat, they can trap heat. When you have your HFC here, that also will lower your global warming, because you see the CH bond here is shorter, right? Not like a CCl bond here. So you notice that these ozone depleting substances are the greenhouse gas. When you replace it, you also can help to mitigate the greenhouse gases and of course the climate change. Okay, so you notice that even when we have HFC, it doesn't mean that they're not greenhouse gas. They are, because when you have CH bond, CF bond, they can also stretch. So what we are saying is, although we diminish the ozone depletions, we still have a substantial amount of the greenhouse gas using HFCs. So that brings to the next question here. Is there a real substitute here to eliminate, right, the problem of ozone depletion and reduce the amount of greenhouse gas? Now, the use of HFC has decreased it to 0, right, ozone depletion potential, but the global warming potential is still pretty high. Okay, so we need more research in that area. Now to find out more about the ozone here, we recommend these two books here. Ozone Hole, Past, Present, Future. I do not know these people, but I've read it and find it highly relevant. So go on and read and do some research. And the other thing is about, I think this is something I would recommend because it's by the United Nations Environment Program here. They collate a diverse background of what the country's policies and the historical heritage of how the ozone investigation came about and what the scientific approaches that the different regions of the world took and agreed upon. Of course, they won't miss out on the Montreal Protocol, the Kyoto Protocol, among other things. And lastly, you might even venture into physics to the atmospheric part to see what are the magics there that is over at the stratosphere. So at the end of this chapter, I just want to summarize that now you should be able to define what is the ozone layer, what is the ozone hole, whether ozone's good or bad, right? And how the ozone destruction worked by the different mechanisms. We didn't talk about just one, there were a few. At least remember 3 of them. Know what it means by the very famous Antarctica ozone hole, right? Evaluate the Montreal Protocol. When was it agreed? What was agreed? Why there were so many revisions? We do not need to know where was it reviewed, or what are the 190 something countries that signed. But at least you know this was significant impact compared to the Kyoto Protocol. And finally, understand what is the effect of the substitute gases on climate change. So with that, I thank you for your attention, and we'll see you next time for the next class. Cheers.